Hi kids, we're back. We're moving on to section 12.3, all about current electricity. We're going to leave what we were just studying, which was called electrostatics. Statics from the word stationary, an object becomes charged and the charge stays in the same position. That's why it's called statics. Now we're going to talk about current electricity. And current, like the current of a river, right? Water is moving, is the movement of charges. And we're talking about electrons here along a closed path. And that closed path is usually called a circuit from the French word circuit. Now, when we're talking about moving electrons in a circuit, we're talking about electrons moving through wires and different components of an electrical circuit. There's two ways of looking at it. One of the ways of looking at it is a model that you can use in your mind called electron flow. And electrons move through the circuit, and you can think of it that way. Another way of looking at it is called, it's got a symbol I, and it's called positive conventional current. Now, all of the mathematics that we will be looking at when we're studying current electricity is based on this model, positive conventional current. And look, it flows in the opposite direction of electrons. So, what I'm going to invite you to do now is pause this video. Okay, I know it's a little bit of back and forth, but I did want to do this little introduction for you as we move from static electricity to current electricity. I want you to pause this video, okay, and watch this video link that I put in to today's announcement. You should have already watched, I think, episode 1, 2, and 3. Yes. And now I want you to watch the fourth segment. Please watch this fourth segment and then go back to the note because it'll be very difficult for you to follow the note unless you have the visualization that you gain from this video. All right, so we're moving from static electricity, where charges are stationary, to moving electrons, a current of electrons. It's called current electricity. Watch that video and we'll be back. Bye bye. All right, so I hope you watched that video. I hope you watched that video. And in the video, you probably saw that there are two types of current, direct current, DC. Electrons always flow in one direction. And this is how we power our cell phones and cars and things like that. Small devices, it's direct current. We're going to spend the majority of our work in this section all on direct current because it's the easiest one to study. The math is easiest. The math for the next type of current, alternating current, that's a little bit more difficult. So alternating current is electrons switch direction. They vibrate back and forth 60 times a second in Ontario. That's the electricity uh, frequency as electrons move back and forth. This is like what we see in when you look at the hydro wires outside or when you plug something into a wall. That's alternating current. Most of the world is at 60 hertz of alternating electrons going back and forth, right? We know about vibrations and frequency. Most of the world is at 60 hertz. There's some areas that are not. Back in the day, they didn't have the ability to do 60 hertz frequency. Even in Ontario, you go back into the 30s, a lot of electricity was being produced at 25 hertz. You could actually see light bulbs flickering. Now the light bulbs do flicker, but so fast you don't notice. So let's get back to what we really want to focus in on, which is direct current. How do we measure how much current there is? Well, we've got an equation. So when we look at current, remember there's two ways of looking at it. There's electron flow, where electron flow moves from negative to positive through a circuit. This is our physical model, but mathematically speaking, we're going to look at something called positive conventional current that flows from positive to negative. This is the mathematical model, and this is the I we're talking about here. And I which stands for current, is simply equal to how much charge passes a point. Either you can think of it this way or this way, doesn't matter, but how much charge passes a point in a circuit in a certain amount of time. So the equation is I for current, which is measured in the unit called ampere, is equal to Q, amount of charge, which is measured in coulombs, divided by time in seconds. So basically the unit for current is the ampere, and it equals a coulomb per second. A is equal to coulomb per second. You're just measuring how many electrons grouped into coulombs of charge pass a particular point in a circuit. It'd be like measuring how much water flows through a particular point, a line in a river or something like that. They even tell you how much water goes over the falls and so per second. Well, we're just measuring how many electrons go through. All right. So I hope you have now completed this video lesson. I hope you watched the fourth segment of the cartoon, which I think was very well done, produced here in Ontario. And then read the textbook. I've given you a few questions to do, and that's it. If you have any questions for me, please feel free to ask me. I'd be more than happy to help you. Thanks, and have a great day.